was in 2019, so but maybe it's still easier. I don't know. So I have a tool for this. I don't know why it doesn't draw the orthocenter, but it's all right. And I think it's swap P and F from what the problem has it. So this should be E, this should be F. K is the circumcenter of AEF, so it's basically the midpoint of AH.
I think E and F are different. I think it says a line through H intersects, so I think it's a random line.
You're right. So it is a random line. So it intersects AB at E and AC at F. And then we could call this, I don't know, P and Q. Okay. And then we draw the circumcenter AF. Yeah, I was gonna say, if this was the US contest, I'd be very surprised if they like called it the circumcenter when it was really just the midpoint of AH. So let's see. So this is K. And AK intersects the bigger circle at a point D. And we want to show HK and the line through the perpendicular to BC meet on the circle. So let's see. So this is D. So the other D, I don't know, we can call it something else. R. And so HK and the perpendicular from D to BC. So this might just be like some, I don't know, phantom points, like trying to work backwards. But yeah, that is the question. All right.
In GeoGebra, it looks like D is just the anti-Steiner point of EF.
It's the anti-Steiner point. Interesting.
Yeah.
Okay. Let's see how we can prove that. I mean, it's probably worth reflecting H over R. So then, like if we could show that, I don't know. We could show angle AHF as angle H prime BG or something like that. Or yeah, basically angle AHE, we could try to show as AH prime B. I don't know if that's obvious. But yeah, if that's true, then that gives like a fairly simple characterization of the anti-Steiner point, right? Like you just see where it cuts to the sides and you just connect A to the circumcenter and see where it meets the circle.
And if that's true, there's also another possibly interesting point. Like if we have, say, D prime such that, like on the circumcircle, such that D prime is parallel to BC, then D prime is antipodal to the point we want to show, and also AD prime is perpendicular to EF. Actually, that's just all true without having D as the anti-Steiner point, I think.
Oh, really?
Yeah, like it's just the like AK and the altitude of AEF are isogonal, and so we have this like we have that
Oh yeah.
like
So this is gonna be.
we have the parallel.
Yeah, these two are isogonal, so since this is the center, this has to be perpendicular. Interesting. So yeah, I guess if we showed it's the anti-Steiner point, how would that help? It's an interesting fact to prove though, but so EF and AG would be parallel. So yeah, AG, like AGDH prime, would be like an isosceles trapezoid. And I wonder if AH, like I wonder if this would be like a parallelogram if we let EF meet GD. Yeah, because if this, well, yeah, if this is parallel to that, then yeah, it would be a parallelogram. Okay, so basically we need to show HK as a diagonal of this parallelogram. I wonder if HP is a symmedian of HAJ. I don't think so though. Doesn't look like it. Let me just try stuff. That's 27 degrees. It's 33. So maybe here's one way we could do it. I don't know if this will work. But I wonder what the antipode of A is. So we know H, L, and the antipode of A are collinear. We want to show H, K, and G are collinear. I'm not sure if this will work actually. So KL. No, I don't think that's going to work. Maybe it would help to draw this point. So, so we know that these are perpendicular. Whoops. I just changed A a little bit and it makes the whole figure jump. It's crazy. So like this would be cyclic, for example. And this would be cyclic. We'd have two cyclic quads. But K wouldn't lie on that circle. I wish it did, but maybe we could let HK meet the circle. And then I don't know if there's anything special about that point, but let's see. I don't know if those really concur. I could check it, but I doubt it. Yeah, those don't actually concur. Okay, so yeah, so I wanted to see if I could figure out anything about NHM, but I don't think there's much I can say about that. Oh, unless NF and those circles concur, but I don't think so. No. All right. So yeah, we have a bunch of cyclic quads. This is cyclic. What else? This was cyclic. But yeah, I don't know how helpful that is. Is there anything special about this point? I don't think so. Unless ML is somehow parallel to HD, but no, it's not. Yeah, it's weird. It's a very flexible problem. Like EF can be any segment, but I just don't see where to go from here. So we know AH is, so what if I draw center of the circle? It's called O. And M is the midpoint. So, so if GJ equals AH, then J should be the orthocenter of GBC. I always forget to use that fact, but that's an important fact. So if you look at triangle GBC, if the problem were true, then J would be the orthocenter of GBC. Yeah, because JL equals LD. There's a couple ways to see it, but and also I wonder if so we have two orthocenters. So yeah, I'm just thinking about how we can work backwards here. So I wonder if we really even need E and F. Like, what if we start with triangles ABC and GBC, and H and J are the orthocenters, and then like I is the antipode of G, and then we take a perpendicular from H to AI. So then we wouldn't even really need E and F anymore, right? We could kind of get rid of them. Well, oh, K is the circumcenter. Yeah, we do need that K as the circumcenter, so we can't just get rid of E and F. So we know K would lie on AD. What else can we say about K? I wonder if we can define K independent of E and F. All right, let's work on this a couple more minutes and then maybe move to the next one. Maybe 5 more minutes. Let's see who is still on. Yeah, I'm trying to work backwards. I did this. Maybe Pascal's theorem helps. So that would mean this point should be the circumcenter of some other triangle. So basically, like, so K is where GH meets AD. And then if we made a similar point where GH prime meets AJ, then this would be the circumcenter. Yeah, so then this line would pass through all those points. So it'd be like by symmetry. So yeah, I mean, we could define the problem this way. We could say let HJ meet AB and AC at E and F, and then show that K is the circumcenter of AEF. And then just define everything the other way. And we know that we basically, yeah, we just have to show KE equals KF. But yeah, I don't know if that's really easier. All right, let's try another problem just to see if we get an easy one. Oh, this looks a little tricky. Oh, the other ones look kind of tricky, actually. This doesn't look that hard, though. All right, let's stick with this for a little bit longer. Maybe 10 more minutes. Yeah, I don't know why this one is so tricky. But yeah, basically we'd have angle AFE is angle DFC, right? And angle AEF is DB. So maybe I could draw those in. So K is the circumcenter. Is there any way we could use that information? Oh, maybe we could show KEFD as cyclic, and that would help solve it. Kind of like that strategy. So is it well known that AD, I guess, yeah, AD is the angle bisector of EDF? I think that can be angle chased. Okay, so yeah, it's all about how we define things. Like I try to work backwards, but I wonder if we could show this as an angle bisector. I think that might solve the problem. Okay, do you want to type it up in the chat? Sorry, Hikari, what the problem you're thinking of is? Okay, I'll take a look at it. All right, so let's see. So if K is the circumcenter, then I think we can show this is cyclic right here. And then from there, oh, these concur. I think this is the key to the problem. So I think if we could show that these concur, I think that might do it. So if we define things the original way, I think we could try to show KH and N are collinear, and then we could try to show that GH and N are collinear. So all right, I'm gonna try Hikari's problem. Just see if we can solve it. So he put it on the Discord server. So let's see. Sorry. I'll copy it. Just delete this for now. We have just a couple minutes left. Okay, so we have triangle ABC, and then we draw the circumcircle. So ACFG and BCBE are squares, but so AC. Do you mean that they're rectangles? So let me draw C at the top. I think it might make the diagram easier. So AC, I don't know if you want to, it's supposed to be like this. Okay, so what if we did this? I think this might be an easier way to do it. Just reflect across. So this would be F and G. And then you're saying BC, D. Okay, it's a rectangle. So ACFG. And BC, well, G, I mean, wouldn't, well, Oops, sorry. So E and G would be the same point then, right? So let's see. So BC intersects AG. So I think G and E might be the same point. So DC intersects AG at P. And okay. And FC intersects B. We're saying E and G are the same points. So those intersect at I'm a little confused. Oh, you think it is a square, not a rectangle. Are they inside the circumcircle, or when it says in circumcircle? Oh, maybe yeah, I'm a little bit confused here. I don't know if it's okay.
Also, what does it mean for like lines FC and BE to intersect in 2 points X and Z?
Oh yeah, what would that mean in general? Yeah, how could those intersect in 2 points, however we interpret it? Z never gets used. Yeah, DEFG is outside of triangle ABC. Okay, so, and then, do you know, yeah, what would it mean for those rays to intersect in? Okay, so first let me draw the squares. Sorry. So okay. Just trying to find the fastest way to do this. Okay. Okay, so BCDE and ACFG. And sorry. DC meets AG and P. Okay. And FC meets BE X. I'll just X. See, I'm not sure what Z is, but I'll just call it X. If M is the midpoint of AB, then we want to show that angle ACM equals BCX. So then you don't even need this square if that's, let's see. So
in my sketch it looks like rather PCA is ACX, which might be what they meant.
PCA
But that is both just 90 degrees minus ACB. So that's not really.
Oh, DE and FG are outside of triangle ABC. So yeah, we drew them outside. So yeah, they're not inside. ACFG and BCDE. But so we drew the squares outside, but they're still let's see, DC meets AG at P, FC meets BE at X, ACM. Okay. Point 8 ACFG and BCDE are squares. DC intersects AG at P, FC intersects BE at X, ACM equals BCX. Yeah, I'm still a little confused. Yeah, I'm still a little confused. ACM and BCX. Yeah, I'm not sure. So yeah, I'm sorry, I'm not sure how to interpret this. Let me check out some other problems before we finish. Yeah, if you can figure out how to what it's supposed to mean, we can go back to it, but I'm a little confused. I think we're close on this. So I'll just check out this one for a little bit. So if K is the circumcenter, then we can show that this is cyclic. And if we let this meet it at N, I wonder if we could show K, H, and N are collinear. How would we do that? So let me hide this. So yeah, we could show K equals KF, and then we could do an angle chase to show that this is an angle bisector here. So we could show it cyclic, and if we let it intersect at N, can we show that K, H, and N are collinear? So I think we could calculate angle KNB, but can we show that angle HNB? I wonder if these two lines are reflections about EF. So wait, H is the orthocenter. Okay, but yeah, no, those lines aren't just reflections about EF. But so KND we want to show as HMD. HND wonder if that's cyclic. Now, yeah, now it looks like those points are cyclic actually. So let's see if that's true. Okay, so I'll try reading the translation one more time. So DEFG So ACFG and BCDE are squares. DC intersects AG at P, FC. See, I don't understand that. FC intersects BE at like how can it intersect? How can FC intersect BE at 2 points? That doesn't. That's confusing to me. And then I don't see why these would be equal. So I don't. Yeah, sorry, I don't understand how it would work. But yeah, here maybe we can show that this is cyclic. So HSND. So how would we show that that's cyclic? We could show that angle ASH is angle HND. Okay, so we want to show HSND is cyclic. How should we do that? Yeah, look at it one more time. HSND. So we'd have BSJ is DAG is DNG. But we don't know that that's DNH yet. So we're trying to prove. Yeah, it's just kind of going in circles. Time is at 11:56. Yeah, so really we want to show HK as a median of AHJ. Can we find what the symmedian is? Doesn't seem that easy. So yeah, I'd like to use this point N right here. I just don't see how to do it exactly. Maybe we here we would have 3 circles with the same radical axis. So maybe we could use the power ratio lemma. Kind of like that idea. So we can get the power of A with respect to both those circles. But I'm not sure what other point. I'm just curious. Let's see what the other ones are. So this looks like a Sharpie double configuration, and then you have, oh, this one looks like it's probably inversion, I bet. It looks like you might invert about the end circle, I bet, or something like that. Yeah, I bet this one is just like inversion about the end circle. And this one, I'm not sure. But yeah, this was surprisingly hard. So I think I'm going to stop here. Thanks everyone for participating. We had a lot of really cool solutions. So yeah, if you end up finding a solution to this, yeah, you post it on Discord. So for those of you watching, if you want to join us in the future, feel free to email me at mgreen801@gmail.com. We meet every Sunday at 8 a.m. US Central Time. So thanks again. Have a great day.